So, minerals are super important, and we use things with minerals in them every day. So, for example, when you turn a light on to see, a light has minerals in it. It is made up of minerals. And Cameron, you like photography, and Justin, you like video games with both, which both have graphics, images, and screens that are needed to be used for it or to engage in those activities. So, a camera and video have compositions that include minerals slash matter. So, a camera has a lens. Oop, I just a camera has a lens, or a video game has a disc, and when you can check to see if it's clean. Oh, I totally skipped line. I apologize. So, a camera has a lens, and a video game a disc or a TV screen, and all of those are objects with matter, and they're composed of different materials that have different properties to help them function. So, for example, when you look at a camera lens or video game disc to see if it's clean, in a way you're checking its luster by making sure that it's shiny or clean, right? So you can see through it. So most people have seen for themselves that the hardness of CDs is not very good because they easily scratch. So this is something you can learn more about, or this is something you can learn about the properties of these items to help you with your future encounters. So for example, now that you know that you would need to be more gentle with the disc and be more careful because they'll scratch. So and discs and other discs are all similar in their materials, right? So technology has advanced so much with the help of minerals and their properties. Without these rocks and minerals, you couldn't play video games and you couldn't take pictures with a camera. So everything is made up of matter, and matter is composed of materials that have properties. And everything we touch has these three things. And we use these things that are composed of rocks and minerals every day. So we can use this knowledge to show or to know more about the composition of these items and their properties. And do you guys know what a geologist is?
Yes.
All right.
Yeah, I
Well,
do.
we're going to be looking at some rocks today. And we're going to be a geologist, and they study rocks. So here we go. Now I would like for you guys to make a prediction. I'm going to rub these two together. This is chalcopyrite, and then this is graphite, which you will often see inside of pencils. That's the lead. I want you guys to predict what will happen when I rub these two together.
Mm,
And then you
I'm
guys will also
assuming.
fill in your charts as well. But Cameron, do you have a prediction of what will happen when I rub these two together?
um, maybe they'll spark.
Okay, that's a good one. What about you, Justin? What do you think?
I think that there's going to be some sort of reaction from the friction created between you rubbing them.
Okay. So I'm now going to rub them together, and then you guys are going to write down in your chart for each different mineral what you observed afterwards or what you can see. So I'm going to rub them together, and then I'll put the camera closer so you can see them. Right? So here's this first one. Can you guys see that?
Mm-hmm.
And I want you guys to write down for the graphite, write down what you see. What happened after I rubbed it? What the graphite looks like. What do you observe? And then once you guys have that, let me know. And then I'll show you guys the chalcopyrite. And you guys are going to write that. I apologize. I didn't even tell you where to write that. Write that under the hardness section.
Oh, gotcha. Okay.
And then here is the chalcopyrite. I rubbed it here. Whenever you guys are good, let me know.
I'm good.
All right. Perfect. And we'll go back up towards the top of that chart. I should have had you guys do that first. I apologize. This is for the, or I'm sorry, the first one is the graphite. What color do you guys see? You can write that in your color box. What color is this? It doesn't have to be super detailed. You can just put whatever color you see. Do I need to show it again?
No, I got it.
Okay, perfect. And then here is the chalcopyrite.
Ebony, can you stop sharing your screen so it's bigger?
Yes. Here, you can turn it. You might see better on this side. Just whatever colors you see, you can just write it down. All right, so we should have color and the hardness filled in, correct?
Mhm.
All right, perfect. Now we're going on to the cleavage. You're going to write this in your description for the graphite. And for this, I just want you to write what you observe about its physical shape. All right. Are you guys good with the graphite?
Mhm.
All right, perfect. Chalcopyrite. What do you observe about its physical shape? Here's another side. It doesn't have to be too detailed. Just immediately when you look at it, what kind of shapes? What do you see with the rock? It's sorry, I just dropped it on my laptop. Are we good for those?
Yes.
All right. And then for this last one, I now want you guys to make another prediction. When I take a flashlight and shine it on the graphite, what do you think will happen? And you can just verbally say that. You don't have to write it down. What do you think about appearance wise?
I make like the shiny parts like kind of not glow, but I don't know what the best word to describe that is, but kind of like glow a little bit.
So glow or a little more shiny, right? Shine a little more. All right, perfect. What
It's
about
gonna glisten.
There you
glisten?
go. That's
That's a
the
good
right
word.
word.
What about this rock, the chalcopyrite? When I put the light on it, what do you think will happen?
I think that one will glisten a lot more, just because like it looks kind of like gold.
Yeah, I think it might glisten a lot more, and then maybe like one predominant color, like maybe purple might stand out more.
Okay. All right. So here's the graphite. I will now, if you need a better angle, I'm trying my best. It's kind of hard to. When I put the light on it, now write down what you observe in the luster part. I'm sorry, I wish the graphics was much better. If it was in person, it would be much easier to notice or see anything. But no right or wrong answers, just whatever you notice is best. So that is the graphite. All right, are you guys good with this?
Yeah.
All right, perfect. Now is the chalcopyrite. So I'm trying to find the perfect angle. Ooh, I feel like it's not good enough. It's like terrible trying to show it through the camera and what you guys should be able to see. For this part. This little shine. All right, perfect. Are we good with those?
Yes.
Yeah, I'm good.
All right. And you guys shared with me and told me. All right. So, what about any conclusions? What did you guys see for that part when I shine the light on? What did you guys observe?
The observation, excuse me. Our observations were kind of right as much as I could see, and tell. But nothing like other than just it becoming shinier, like no physical or anything changed.
Yeah, very good. So I just heard from you. So what about you, Justin? Let's go back to the hardness section when I rubbed them together. What did you observe about the graphite?
You get like scratched up.
It got really scratched up. What about the chalcopyrite? What happened to this?
It was fine.
Yeah, it stayed the same, right? So you may be wondering, why was the graphite scratched up? Why did the chalcopyrite look the same when they were rubbed together? Well, I will tell you why. So we remember that rocks are composed of at least one mineral, okay? And minerals have a list of properties that they can have. And so what I just showed you were a couple of these properties. So one of the properties of a mineral is hardness. And hardness can be determined based off of an object's ability to resist being scratched. So to test this out, we rubbed the two minerals together, but another way is if I wanted to, I could have scratched it with my fingernail and you could have noticed about the same things. So the hardness, to test the hardness of a mineral, you can use the Mohs hardness scale, which goes from 1 to 10. The chalcopyrite mineral has a hardness of 3.5 to 4 on the Mohs hardness scale. And then the graphite mineral has a hardness of 1 to 2. So just based off that and hearing those numbers, you know that based off the scale, whether we scratch this or not, we would know that it's not as hard as the other mineral. So the therefore the chalcopyrite has a greater hardness than the graphite, and the Mohs scale can be used to check the numbers they correspond to on the scale. You can also test this out for yourself by using a hardness test kit, which comes with all these different types of tools. So the chalcopyrite is harder than the graphite because it resisted being scratched. So now we're going to make some more predictions. We're going to do this new but similar experiment. If I took a hammer and I smashed these two minerals, what do you think would happen? What do we think would happen? Cameron?
Um,
How about we start with the graphite? What do you think would happen with this?
I think with that, like if you hit it once, I think it would just kind of break in half.
Interesting.
Maybe more than one break. Maybe it might be like a couple different pieces, but I feel like just because it's like the way that it is, it might just break in half.
Yeah. What about this, Justin? If I took the hammer and I broke this chalcopyrite, what do you think would happen?
I think like it might just like chip off, maybe like dent it a little bit. Don't think it's gonna like break as much as the graphite.
Okay. So we are now going to test that out. I have my hammer and I have my chalcopyrite. I will do first. I'm going to smash on the ground though, so I don't get pieces all over the computer. And then I will lift it up and show you guys what it looks like afterwards. And so now we are moved on down to, if you are looking at our sheet, we're down to the elaboration, I believe. Yes. So I'm now going to smash them. And here are the pieces.
Huh.
So I just want you guys to look at this
Wow, that was a big
and
rock.
look at the shape. And for this part, I want you to notice. So cleavage, we looked at it earlier, and I had you guys just look at the physical shape. So the cleavage is when you're looking for that, you can also use those little images I showed you. A cleavage is if there's at least one flat or smooth surface that goes straight across. Do we think this has cleavage?
Mm,
What do we think? When it breaks, any piece, it doesn't matter.
are you talking about like the broken part?
All of it. So cleavage is based
Okay,
on
the
the
whole
way
thing.
when a mineral breaks, does it have a flat or smooth surface?
That one does not look like it does.
No, so if you think the chalcopyrite does not have cleavage, then in the chart you will write no cleavage. And then I will do the same with this, the graphite. I've broken the graphite. Does it have at least one smooth or flat surface?
Yeah.
Yeah, going all the ways across. It's flat and it's smooth. It's very hard to tell. Minerals are very detailed and this camera is not that great. But yeah, it has cleavage. So you can write cleavage in that section. So for our next prediction, instead of rubbing the minerals together for the hardness, we can do another test, which is, I know I keep bringing out all these scary tools, a knife. So I want you to make a prediction now on what you think will happen if I use this knife and rub it against the material or try to cut it. Do you think it will resist the scratch or not? What are our predictions?
What was the chalcopyrite again on the Mohs hardness scale?
A 3.5 to 4. And if you just so you know, your fingernail is about 2.5.
I think like the knife is gonna like cut it a little bit and give it a slight indent.
Yeah.
Okay. So let's try this out. I'm going to put it down and then I will show you guys so I do not cut myself. Oh. It completely like chipped and broke off, so I guess that kind of tells you. So this is where I use the knife. What do we observe?
It definitely broke a piece of it off.
Yeah, so can it resist being scratched?
With the
No.
knife? No.
No. But it did when we rubbed the two minerals together earlier. Interesting. So now I'm going to do the graphite. What do we think is going to happen?
I think it's definitely gonna scratch that.
Definitely. All right, let's see. I'll do a couple in a row so you can see it easier on the camera. What do we see?
Oh yeah. Definitely
Yeah.
made an indent.
So before
Yeah.
we rub these together, this got all scratched up. But now when we take the knife and rub it on there, they both get scratched up. Could anybody tell me why, or do we know why that might happen?
Because the knife is harder, the knife blade is harder than the graphite and the chalco.
Yeah, exactly. So we're saying that it's much higher on the hardness scale, right?
Mm-hmm.
Perfect. I love it. All right. So now we went over those. And then luster. We'll kind of look back at luster again real quick. So before for luster, I just shined the light and I had you guys tell me what they saw. So I'm going to shine the light on again. And now that we know a little more about luster, we have two groups. I'm not going to go into all the details of the different names that they could have, like pearly, luminescent. There's so many different names. For this lesson, I'm just going to have you guys label it metallic or non-metallic. And if you guys look in your images, it has quite a few different names for the type of color they can have. And then there's also a bunch of different crystal names or mineral names. So what do we think when we look at the chalcopyrite? Does it have a metallic or non-metallic luster when I shine the light on it? What are we thinking?
Metallic.
Yeah, even when I turn it, you kind of see the light like bounce off of it, right?
Yeah.
So that's metallic. You can go ahead and write metallic in there. And when I shine it on this graphite, which this can kind of be a tricky one because it could really go either way, what do we think? Metallic or non-metallic?
I want to say non-metallic.
So this one
tricky
was a little trickier because it could be dull because of its, dark gray kind of color, but it could also be metallic. So I accept either or, depending on, I guess, just the graphite. So yeah, it could definitely be either or. So we talked about properties and compositions. All right. And so minerals are naturally occurring inorganic solids, and they have a definite chemical composition and an ordered internal structure. So minerals make up a rock's composition. And this means that rocks are composed or made up of minerals. That's what composition means. It's something that's being made up of something else. So minerals are definitely a type of matter. Do you guys know what type of matter it would be?
Solid.
Like a solid. Very good. Yeah. It would be a solid. And matter, minerals are a type of matter because they take up space and they have mass. They also have different properties and compositions, and minerals can be described by their compositions and properties. And properties can be defined as characteristics that help us classify one substance from another one. So, one of the properties you can test in a mineral is the hardness, which we did today by checking its resistance to being scratched. So, for example, the knife has a greater hardness property than the chalcopyrite and the graphite, like you said, Justin had said. And this is because the knife could scratch both of those materials, right? And their hardness was low because they couldn't resist being scratched from the knife. And to check the cleavage of a mineral, we're looking for at least one flat and smooth surface. And you can break it or you don't have to break it to be able to check that. We saw that the hammer broke the graphite easily since its hardness property was really low. So as soon as I smashed it, it broke immediately into two pieces. The hammer broke, okay, the graphite easily, and then when we tested the cleavage of the property, it broke the graphite into a smooth and flat surface. Okay? So it had cleavage. It was smooth and flat. On the other hand, when we broke the chalcopyrite, it had no cleavage. And here's all the other pieces. Depending, some places say that it has very poor cleavage because they kind of have like a flat surface, but it just really depends. Every mineral, even when you test it out with certain things, can all be different. And then I have my, trying to think, I think I'm at like 24 minutes now. I have my test, which you guys can go through and answer those questions. If you can pull those up in your document real quick.
Do you want us to just email the document back to you once it's filled out?
Yes, you can.
Oh, I printed it out and doing it on paper.
That's fine. As soon as you guys finish, we can talk about it.
I'm good.
Right. How about you, Cameron?
Yeah, I'm good. Sorry, excuse me.
You're good. All right. So number 1, list at least 2 physical properties of minerals. What did you guys say? What do we think?
Color and hardness.
Color and hardness. That's correct. Those are 2 out of quite a few of the different physical properties. Number 2, use the word bank to fill in the blank with the appropriate answer. Minerals make up a rock's
Matter or composition?
I put composition.
composition, right? Because remember,
Yeah.
when something is composed of something, that is everything that is in. Like if you think of a chocolate chip cookie, it's composed of a bunch of chocolate chips, right?
Yeah.
So it's something that it's made up of. Number 3, when examining the hardness of graphite, it is harder than chalcopyrite. True or false?
I put false.
Yeah, I put false.
That's correct. The graphite is not harder. It was not harder at all because it completely got scratched up. Number 4, all objects with matter have
A
Composition of-
composition of minerals A.
Yeah.
but so let's listen to the question again. Not all rocks with matter have blank, but all objects with matter have. This one was a bit tricky because I put minerals and rocks in a bunch, but they all have composition. This is just an in general question. Any object with matter is composed of something, right?
Oh, tricky.
If you develop this lesson again, what would you use to test the hardness of the mineral other than a knife? So we rubbed them together and we used a knife. What else could you use?
A diamond.
Yeah, I said a piece of glass.
Yeah, any sharp object, a coin, your fingernail, right? Anything you could really rub against it. So 6, select the most appropriate definition of matter. What are we thinking?
I did
Matter.
B.
You said B?
Yeah.
Yeah, matter is anything that takes up space and has mass. All right, you guys all did awesome. That was my lesson. Thank you.